know this one? What is the difference between two? Huh? Same. What is the difference? Huh? The answer is no. That is both are same actually. Because in any psychology or anything, because when we start the thing, we did overthinking, mistakes is happening. In psychology or anything carbon change, first thing is the numbering the compound. Numbering the compound starts from heteroatom. In this numbering starts from here 1, 2, 3. Here also numbering starts from 1, 2, 3. This is 1, 3. 1, 3. Diagonal. Both are same. Because position is not defines the. We see the numbering. After that, we say it is greater than. If you think over this, it will spoil. Then we see the synthesis and application of form of part of 1, 3 diagonal. One more question. For that class. This is aromatic, non-aromatic, or anti-aromatic. Can anyone say? Aromatic, anti-aromatic, or non-aromatic? Which one is this? Huh? Non-aromatic. Another answer. Oh, it is non-aromatic.
There is no resonance.
Huh? Resonance is there no? Sorry. 1, 2, 3.
Conjugation.
Conjugation is not there. If conjugation is not there, it is non-aromatic. What is a consonant? What is a consonant?
4n plus 2 4n.
4 plus 2 electrons. There is no pi electrons in this.
Yeah.
It is not from alcohol. 4n electrons also not there. See, we are saying non-aromatic means it is sp3 hybridization. If any compound contains sp3 hybridization, directly we say it is non-aromatic. 1 sigma 1 sigma sigma sigma. S1 plus P3. sp3. Directly we say non-aromatic. Don't think about conjugation, planar, cyclic. No, you need to think about that. Mechanism and synthesis and application part of this. This PPT contains introduction, synthesis, application, limitation, summary of the 1, 3 diagonal. Introduction. It is a protecting carbonyl group in various synthetic pathways. It is also used to unplug and Cori-Segrach reaction to generate nucleophilic carbon transcenders. I will see in mechanism, showing mechanism. New system will write the mechanism. You will understand it. What is this? For saying that only you are taking this picture. All right, now. Lewis acid. What is the role of Lewis acid? Can anyone know what is the role of Lewis acid? What is this? Electron pair. Electron pair. Electron pair acceptor means donor is there. Donor is oxygen. Donates the electron to Lewis acid. Generate the. I can write like this. Anyone understand matter? Just don't play the positive charge on the oxygen, just positive charge satisfies the this. Positive charge came on carbon. Now carbon needs some nucleus. Add 1,3 diion. You know that? No? Water is removed, acid. Then from here goes attack on here. Correct? Not understand. It's correct. Correct only, no? In this situation, it is not understand in this situation. Can I write clearly? Then you can understand.
Okay.
Why is it? Can I write clearly?
It's okay.
Because I am not writing clearly. You know, if I write clearly, you can understand.
It's okay. Age different.
Okay? Okay? Okay?
Yes.
Just deprotonate it.
Understood.
From here. You know this one? BULL. Minus 48 degrees Celsius. I forgot to say. Reagent. Yes. Reagent. Tetrahydrochloride. Yes. This is the Cori Seebach reagent. That step, that formation intermediate is called Cori Seebach reagent. Antar reagent. Rule is called Montgomery type. Where we use this reagents in normal organisms. That's it. Implication. Then these reagents reacts with alkyl halides alpha hydroxy carbon into nitrogen acid chloride epoxides for form beta hydroxy carbonyl compound. Beta hydroxy carbonyl compound and reaction in solid CO2. I will show from here in PPT. When alkyl halide react with this one 1,3 dithiol with BF3 acid. What is BF3? Lewis acid or Lewis base? Earlier I discussed the Lewis acid. It is Lewis acid. Again, form 1,3 dithiol and react with again butyl ester or tetrahydrofuran. Tetrahydrofuran is a 5-member ring with 1 oxygen. And carbon with negative charge and undergo SN2 reaction. How did you say it is an SN2 reaction? Can anyone say? Huh? No, one step reaction I know. It is SN2 reaction. How did you say it is an SN2 or SN2? What is the condition for SN2 reaction? Okay, it's from that side. Concerted mechanism happens. Reactant upside from that side. This is as well. See, here primary is used carbon. Primary carbon involved in the reaction. Then it is an SN2 reaction. Form that lithium instead of that lithium here this part will be as in the compound. Again it reacts with H3Cl2 and H2O and alcohol form and keto group and 1,3. This one is compound. Catalyst is compound. This is one of the applications when reaction with alcohol to form aldehydes and keto. If we take your aldehyde, we obtain keto. Yeah. Take an aldehyde ketone group. If I take ketone, maybe aldehyde. I also don't know. We can write, then only we get to know. If I take aldehyde ketone, if I take ketone, first of all, ketone not able to take an hydrogen we can. It will take. We will check it later.
Sir, I have one doubt.
Yes.
Yeah. So afterwards I will clear everything. In between,
Sure.
how you cut? That's why. Doubt section is there. I will give you the reaction is carbonyl group to form an alpha hydroxy carbonyl compound. We know that hydroxy means what is hydroxy? OH group. Now OH group present in the alpha carbon position is alpha hydroxy carbonyl compound. See, in product, this is alpha carbon. Alpha carbon, we know that alpha carbon must be sp3 hybridization. Yeah, it is an sp3. Hydroxy group is there. Alpha hydroxy carbonyl compound. First we take reagent. Final step. Aldehyde. Write it. We get this one and react with HgCl2 and H2O and methyl cyanide and we get this test. You work out it in the environment, then only you get the result. CO and OH group. Alpha hydroxy carbonyl compound. Hydroxy come with alpha position only. Alpha have sp3 hybridization only. Alpha carbon. Reaction with nitrile group to form a dicarbonyl compound. What is nitrile group? You know that? Huh? What is nitrile? C. What is cyanide? Huh? What is the difference between nitrile and cyanide? both are same.
Then why you take a different?
Huh? Prabhakar. Another name for you. Nitril as usually we use in IUPAC names. Cyanide we are usually using common. That's it.
But isn't cyanide double bond and nitrogen triple bond like that?
Huh?
No
Sir.
difference only is there.
No, both are sir. C triple bond then this cyanide. C triple bond then this nitril. Nitril reacts with lithium. That reagent means fantastic reagent. See, polarity exists here. Carbon and nitrogen, which is more polar. Electronegativity among carbon and nitrogen, which is more electronegative. Nitrogen, as you know that. Then one shift here, positive charge found here, negative charge jump from here to here. Again, negative charge found here, as shown in here. Again, lithium come attack to the negative charge, neutralize that one, and again undergo hydrolysis and heating to give this compound in this system. Oh, see, double bond N instead of imine group, carbonyl group will come when we do hydrolysis. Again, we do HgCl2, H2O, and in ethanol to that one we get dicarbonyl group. Here, what we take cyanide, obtained compound is dicarbonyl. Cyanide have C double bond. Here one C double bond was generated. Total 2 is come. Reaction with acid chloride to form carbonyl compounds. What is carbonyl compounds? See, this is little bit tricky. Carbonyl compounds are where carbon contains two functional group aldehydes and one hydroxyl group is called carbonyl compound. For example, one and three are carbon aldehyde and another thing is hydroxyl group. It is carbonyl group. We generate the carbonyl group by taking acid chloride. When we take acid chloride, reacts with that reagent 1, direct and we negative group attack here and here go there, negative charge form on oxygen and we do protonation workup and alcohol is formed. Now here to remove these two things and form instead of that one carbonyl group. To do for that one we use methyl cyanide. Back step what we use? Methyl cyanide to generate carbonyl group. Same thing we use here, methyl cyanide to generate carbonyl group by removing this one. Reaction with epoxide to form alpha hydroxy carbonyl compounds. We take the reagent and react with BULI, you know, butyl. Structure of BULI, anyone right? Structure of BULI. Structure of BULI, you can write. Butyl. React with tetrahydrofuel and form epoxide. Here what will happen? Hydrogen substituted by lithium. Again, negative charge on the carbonyl group. First, butyl, lithium and THF react to form this one. Again, from here negative charge goes here. You know that to show epoxide formation. We studied in second semester. This type of reaction. No, in this place, carbon is there, negative charge is there. It is different. Different is there. We consider Rho, negative charge, carbon. Same reaction we studied in previous semester. When carbon reacts with epoxide, what will happen? Just go there, just attacks a positive charge. Here comes again alcohol form, carbon will form. Sorry, here beta hydroxide. See, product you get alpha beta. Beta hydroxy carbonyl group. You can check this beta hydroxy. Mistake. Reaction with solid carbon dioxide to form alpha keto acid. Solid carbon dioxide. Carbon dioxide exists in solid form. Carbon dioxide. What is the hybridization of carbon in carbon dioxide? Can anyone know? What is the hybridization of carbon in carbon dioxide? See, here polarity exists. First of all, carbon dioxide is a polar or non-polar? Polar. Cancel with each other, non-polar. It is a linear molecule, it is a non-polar. Still it is reaction occurs here. It is a non-polar. Charge will not occur. How reaction occurs here? That's why chemistry behind we learn first. Then only we can understand the concept clearly. It is a non-polar, we know. CO2 is a non-polar. Charge is not formed in the CO2. But here charge formed, no? How? Because I also don't know. This one. But I can tell you. See, here CO2 go here and form here, H2O and hydrolysis and as simple as that to generate carbon group, methyl cyanide, alpha beta acid. Limitations. While welcome limitations of these reagents, every reagent have their own good properties and bad properties. We need to pick if good properties only. Here it is a more than 75% good properties, advantages. We need to use that reagent more, and that reagent will come with less cost. We prefer like that. Disadvantages of this 1,3 diagonal reagent is effective for certain reaction. It is applicability is limited to specific substrate. One is limited to specific substrate, particularly those who carbonyl groups. It may not be suitable for protecting other functional group. It will only specifically only for carbonyl group. It is not suitable for another functional group. If any reagent, it is applicable for carbonyl group as well as other also. Then only it will take. Diagonal groups can be oxidized due to sulfoxide or sulfonones undergo certain conditions which may complicate reaction pathway. Although deprotonation is generally straightforward, some conditions may lead to side reaction or the formation of unwanted products, requiring careful optimizing for the deprotonation step. In deprotonation step, we need to take care gently. 1,3 diagonal can be sensitive to moisture. Well maintained laboratories we require for using 1,3 diagonal because it is sensitive to moisture and should be handled under anhydrous condition to prevent hydrolysis and degradation. 1,3 diagonal undergo hydrolysis quickly. We see every application hydrolysis is there. That's why it must be anhydrous condition and hydrolysis to prevent worry. See, this is added mechanism. For this one, every application, I added one more thing. I show you each and every step. This is just adding reagents and getting these things. First, alkyl halide, HMPA, epoxides, tertiary nitrate, ester, ketone, ClCO2, carbon dioxide. Ester, we get respective product. Majority we use hydrolysis and HgCl2 and HgCl2 to get final product. This is the final step.
First application. Their reaction with alkyl halide is there, but you have taken aldehyde as the reactant. How is that? And to form
Reaction with alkyl halide to form aldehyde ketone.
you have taken aldehyde only.
It is printing mistake. Instead of alkyl halide is the class. Starting initial. Anusha is in initial.
Which is the reagent? So transformation is your alkyl halides, your oxide reaction.
No, aldehyde
Alkyl halide, you are converting into aldehyde of ketone. Not only source. Right there is the preparation cell, no, that is the reagent. So you need to use it for the conversion of alkyl halides to aldehyde. The first step till diethylamine preparation is the reagent preparation. Then alkyl halide we are using as a reagent and converting the alkyl halides to respective aldehyde of ketone. Diethylamine is the reagent.
To learn this mechanism, it is easy to understand each and every application.
What is the long reagent? For a C batch reagent, down there is a long reagent. The reagent you are considering as a long. What it is? So in the exam, I had asked the corresponding reagent. Suppose if I had asked long reagent, I think in the syllabus it is long. Diethylamine or long reagent. So you are not explaining anything about long reagent. Why it is called as a long? So the specialty of this reagent is it is not. If you consider the aldehyde, carbon is electrophilic in nature. So electrophilic site you are trying to change it into the carbanion site. So it is acting as a nucleophile. So you cannot use the carbon directly. So if you use this for any of the reaction, usually electrophilic. So and the nucleophile prefers to attack on the carbon. But your intention is to use it as a nucleophile. In such cases, you need to use the propane 1,3-diethyl and then prepare the 1,3-diethyl as a reagent. And in this case, 1,3-diethyl, once it is formed, then if you see the specific carbon, the carbon in presence of base, it will act as a nucleophile rather than acting as an electrophile. Switching of polarity from the electrophilic carbon into the nucleophilic carbon,
Positive charge and negative charge.
that you need to start explaining in the beginning. So or else there is no point in explaining why what is long reagent. Long reagent is sign conversion.
Sign conversion from positive to negative.
Positive means electrophilic carbon into the nucleophilic carbon. So So all these reagent is mainly you are not using as an electrophilic carbon for the as a reagent. You are trying to convert this particular carbon into the nucleophilic carbon. So for that you are using a protecting step. There are two steps here. One is first is protecting.
This one.
That is the protected one. Which is the protecting agent?
This one.
Propane 1,3-diol
Protecting.
is a protecting agent.
Protecting the.
Which protects the carbonyl carbon. So thereby it forms a 1,3-diol in the first step under the Lewis acid medium.
That is only main step.
That is the main step and it is the reagent preparation. Suppose if you try to take aldehyde and then try to directly treat with the butyl lithium, let us assume, what will happen? Don't use the dithiazide.
If this go to there and it will come here.
So this butyl will be, that is butyl group is access and nucleophile. Nucleophile attack over the carbonyl carbon and then shifting of bond. What product you will get? Just aldehyde and then try to treat with the in-butyl lithium. What will
Addition
be,
of carbon with the structure.
what will be your end product?
Alcohol or aldehyde. Alcohol only.
So you will get attack on the carbonyl carbon and then you will get alcohol. But if you use this dithiazide,
You get variety of products.
what product you will get here? After this, once it is 1,3-diethane derivative is formed, and then if you try to treat with the other electrophilic based reactants, then automatically this will act as a nucleophile. Next step. Okay. Next step. Treat with the alkyl halide. Suppose if you have a dithiazide derivative, this is the derivative now. Then treat with the
Concentrate mechanism is that takes place
concentrate.
there.
This will act as a nucleophile now. The carbon sign is negative. But if you see the first step, it is positive carbon. Carbonyl carbon in
Yes.
aldehyde.
It takes alkyl halide only here. This step we consider.
So from here to here conversion is you are saying alkyl halides to aldehyde or ketone preparation.
Yes. From reagent to alkyl.
Alcohol is conversion of electrophilic carbon based in system into the nucleophilic carbon. Suppose if we directly use the aldehyde, here aldehyde we can use it for the preparation of dithiazide derivatives, either simple aldehyde. Simple aldehyde is formaldehyde, wherein both the sides you have an HNH, or you can use aldehyde. You cannot use the ketone for the preparation of dithiazide reagent. Why? Ketone you cannot consider in place of aldehyde to prepare the derivative. Whether you will get dithiazide derivative if you start with the ketone. In ketone also you have a carbonyl carbon. It is an electrophilic carbon. Can we sign the electrophilic carbon of ketone into the nucleophilics in case of carbonyl carbon via this dithiazide method? Is it possible or not possible? That's it. It is there in your reaction method only.
Here we get ketone.
Ketone. What will happen?
CH3 will get.
CH3. Let us take acetone. Both the side you have CH3, CH3. And then try to use 1,3-dithiol, propane dithiol.